Hello, I'm Tim Sandle and I'm responsible for the microbiology, risk management and sterility assurance functions. And I'd like to talk to you today about wet equipment and wet loads and why this matters in terms of producing a safe and efficacious product made to the highest quality standards. So with wet equipment, this presents a challenge, particularly over a long period of time. So our starting point of our challenge is with water. Now we can't escape water from the pharmaceutical environment. We need it to clean equipment. We need it to prepare cleaning and disinfection solutions. And we need it to formulate the product. Most of the product is in fact made of water. But water can present problems when it's unwanted. Things can be left wet, or water can produce aerosols, and aerosols can travel quite wide distances, either by mechanical action like spraying or through being carried in air currents. Second thing about water is that there are lots of different types of bacteria, types that we call gram negatives, which is just a reference to what colour they stain in a laboratory, which not only survive in water but they also thrive in water. So by thriving we mean that they can multiply in number, and bacteria reproduce by a process called binary fission, and essentially that means that they continuously create clones of themselves or genetically identical cells over a period of time until they've exhausted any of the nutrients that are available. So they go through these various generations. Now this is a problem, particularly with the gram-negative bacteria in wet conditions, because they can fairly rapidly increase in numbers. So different types of bacteria have different generation times. But some of the ones we're concerned about, say like pseudomonads, which are common water type organisms, these can double in number every 15 to 20 minutes. So a small population will become a large population within a few hours. Another concern in relation to water and damp environments is fungi. So on the slide we have a picture of a petri dish, and some special photography has been used to show the spores rising up from the petri dish. So many fungi release their spores like projections, and these are then carried in air streams. And if these spores land in environments that are damp or wet, this creates the best conditions for the fungus, and again within a short space of time we might see visible mould, particularly the black or olive green coloured mould that can appear on walls and surfaces in uncontrolled conditions. Looping back to bacteria, there is another concern. So here we have a bacterial cell undergoing what's called lysis. Okay, so lysis is just a fancy word for the membrane around the bacterial cell rupturing and the contents spilling out. And this is often what happens when the cell dies, or we deliberately try and kill the cell by heat or by chemicals. It will release its contents. And the problem is with the gram negatives, these water loving organisms, is that their cell membrane is composed of a substance called lipopolysaccharide, and this is more commonly known as endotoxin. An endotoxin is a problem because at a sufficient number, if the endotoxin gets into the human blood stream, it causes a fever reaction, what's called a pyrogenic response, and it also can cause something called endotoxic shock, which is essentially septic shock. And endotoxin is really difficult to remove. It cannot be filtered, and if it ends up in the finished product, then there's very little we can do other than test for it. So it's important that things are as dry when they need to be dry. So this is for vessels and for items coming out of autoclaves. So dry is free from visible moisture. So that means you cannot see any evidence of moisture at all. It would also mean that if you were to touch the surface, you would feel no dampness or wet at all. So we are using an absolute term. Either something is dry or it is not dry. So we need to practice good drying practices and also avoid something that has been cleaned and dried from becoming recontaminated. So we don't want clean and dirty equipment to be located close to each other. We also don't want to leave clean and dry equipment in wash bays where it can become recontaminated with aerosols. And we want to know that we can spot this by having a status label in place that's indicating whether something is in fact clean and dry. So there are different ways to dry equipment. There are automated processes using compressed air that can rapidly dry equipment, or sometimes the application of 70% IPA can then dry, because as the alcohol evaporates it takes more water with it as well, so that can increase the drying rate. Or there are drying cabinets like the example on the screen, which is a GenLab cabinet, and these can dry very effectively and they don't cost very much. They're £2,000 or £3,000 each. So provided they're loaded properly, provided they're at the right temperature for the required rate of drying within a particular time, that the items are left in for the right time and the doors are fully closed, then we can have effective drying very easily within a fairly short space of time. With autoclave loads, wet is again a very dangerous concept. So generally when things come out of autoclaves they are wrapped, and it's very important for effective sterilisation that the package is not damaged, it's not torn, it's not punctured, but also it's not wet. So on the slide there is a picture of an autoclave load that is obviously wet around the area that I've circled. And when an item is wet, it simply means that it's non-sterile and therefore could cause a harm to the product and to the patient. And the reason for this is because where there is water, it means that the autoclave has not functioned properly in relation to its steam quality, in terms of the dryness of the steam, all the areas where the steam is supposed to have reached every aspect of the load. And here we get the risk of insulation, and when we get insulation we're not getting adequate steam penetration, therefore we may not be killing all of the microorganisms that are present. Another risk of course is when the item comes out and it's slightly wet. If we were to leave it, say let's say under a grade A unidirectional airflow and think that might work, it doesn't. One, because we've still got the non-sterility, and two, it's quite easy to get recontamination from anything from the external environment, including the person handling the material. So if something is supposed to be dry, and remember dry, we're talking about an absolute term, report it to your supervisor. This could be a vessel, it could be an autoclave load. If it's repeatedly wet, then that's probably a sign that the process is not working properly. So we must raise an engineering action. If for any reason you think it has been used, like a wet autoclave load or a vessel that's been used say after 10 hours and it's still potentially wet, then this must be reported to Sterility Assurance Department for an emergency product risk evaluation. Okay, so equipment must be dry, or if it cannot be dried it needs to be used within 10 hours. Drying, where we seek to dry things, must be effective, and we need to use things like compressed air or good quality drying cabinets. The risks are bacteria growing, fungi landing in terms of spores and then growing, bacteria releasing endotoxin that's really difficult to remove from the process and causes considerable patient harm if it was to be present. And with autoclaves, wet again is an absolute term. A wet load means non-sterility, so they're really important points. So thank you for watching this video. My name is Tim Sandle and I represent microbiology, risk management and sterility assurance. Hopefully this has been of interest. Good luck with the rest of your day. Goodbye.